All right, let's look at this example here. And in this example, they give us this polynomial and they want us to find the zeros and their multiplicity. So let's use what we know regarding this. So we know that the upper bound for this is 2 and the lower bound for this is -3 from the previous video. Let's dissect this, right? So here, if we look at using the possible rational zeros theorem, right? So let's deal with our p's, right? So our p's, factors of 20. So we've got plus or minus 1, plus or minus 2, plus or minus 5, nope, 4. Plus or minus 4, plus or minus 5, and plus or minus 10, and finally plus or minus 20. Okay, now for Q, we're looking at factors of 2 here, so it's going to be plus or minus 1 and plus or minus 2. Okay, so in this case here, if I'm looking at P divided by Q, right? So obviously 1 is going to give us all of these, right? So it's just going to be the P's again, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Now we're going to divide all the p's by 2, right? So that'll give us a half. So we got plus or minus 1/2. And then 2 divided by 2 gives us 1. 4 divided by 2 gives us 2. 5 divided by 2 is new, so plus or minus 5/2. And 10 divided by 2 gives us 5, and 20 divided by 2 gives us 10. Okay. So now here's where, again, we're looking for testing, things to test, right? So obviously we want to use plus or minus 1 to start with. That's the easy one, right? So for positive 1, all we do is add up the coefficients, right? So 2 plus 1 is 3, plus 9 is 12, minus 32 is -20. Plus 20 is 0. So let's just do that one more time, make sure we didn't make a mistake. So 2 plus 1 is 3, plus 9 is 12, minus 32 is 20, -20, and then plus 20 is 0. So yeah, so 1 works, right? So let's do 1. Okay, let's factor out x. So one of the factors is going to be x minus 1. So let's use 1. And let's do our synthetic division. So 1, 0, 9, -30, and 20. Because remember, placeholder. Okay, so now I'm going to do my synthetic division. So 2, 2, 3, 3, 3, right? Yeah. 2, 2, 3, 3, 3, yep. So 3, 12, 12. Yeah, so this is just working out the way. So 12, -20, -20, 0, right? All right. So now my polynomial is now degree 4, so it's going to be 2x to the 4th plus 3x cubed plus 3x squared plus 12x minus 20. All right, now, oh, guess what? Let's try 1 again. Let's try 1 again, right? So if it worked once, it might work twice. So let's do it again. So now we're going to add up the coefficients for 1. So that's going to be 2 plus 3 is 5, plus 3 is 8, plus 12 is what? 20, minus 20, 0. It works again. So now we know that 1 is a 0 with a multiplicity of 2 so far. Okay? So now let's try it again. Okay? And now our coefficients are 2, 3, 3, 12, and negative 20. Okay? So I drop the 2, I get 2, 5, 5, 8, 8, 20, 20, 0, right? Okay, so now my new quotient becomes one less degree. So now it's going to be x to the third, so it's going to be 2x cubed plus 5x squared plus 8x plus 20. Now, oh cool, now I can factor this by grouping. This is factorable by grouping. You could tell because I can factor out an x squared here, and that'll give me 2x plus 5. And if I factor out a 4 here, I get x plus 5 again. Oh, hold on a second. No, I get 2x plus 5 again. So I get 2x plus 5 if I factor out x squared here, and I get 2x plus 5 if I factor out a 4 here. So we can use factor by grouping. So let's do that. Okay, so now I don't need any of these because I already got enough where I can just use other tools in my toolbox now. Okay, so far, before we get any further, what we found is what? We got two factors. We got x minus 1 squared. Multiplicity is a factor, right? Okay, so now I don't need any of this, right? Okay, so now I'm just going to rewrite this. So 2x cubed plus 5x squared plus 8x plus 20. Okay, now I'm going to factor that by grouping. So now I'm going to group these two and these two. So again, I'm going to factor out x squared here, which is going to give me 2x plus 5. And then I'm going to factor out a 4 here, which will give me 2x plus 5. And now I can factor out the 2x plus 5. And that leaves me left over x squared plus 4. Okay, so now I've got a linear term here. So that's going to be another factor here, 2x plus 5. And this is a sum of two squares. Okay, so this is going to factor into x plus x plus 2i and x minus 2i, I believe. Okay, now I'm going to solve this one differently than I did in a previous video. In a previous video, I used the quadratic formula, which is fine. But I can also just use the other tools we had, which is just set this equal to 0 and solve using the square root property. Okay, so let's do that. So x squared plus 4. By the way, I'm using the zero product principle here too, because we're solving this equal to 0, right? We're looking for zeros, right? So keep that in mind. So I'm going to set this equal to 0, and that means x squared is equal to negative 4, which means x is equal to the square root of negative 4, and look at that, or plus or minus, right? So then I get x equals plus or minus what? 2i. which is exactly the two factors I got. So if the zeros is plus or minus 2i, right, then the factors are x minus 2i and x plus 2i, okay? So in this case here, we've got x plus 2i, x minus 2i. Now, what did they want? They wanted us to what? They want us to find the zeros and their multiplicity. So what are the zeros? The zeros are 1. Oh, we didn't find the 0 for this one. So the 0 for this one is going to be negative 5 halves. Which, by the way, was one of the candidates on our list of possible rational zeros. Okay? So the final answer for our zeros would be as follows. So here are the zeros and multiplicities, right? So we're going to have 0, 1, negative 5 halves, 2i, and negative 2i. And this would have a multiplicity of 2, 1, 1, and 1. And notice that we have, by counting the multiplicities, the zeros by their multiplicities, we have 5 zeros, which adds up to the degree. So we know we have no other complex zeros. We found them all. Okay? And notice that they're all within the bounds of negative 3 and positive 2. All right. Have a great day.